All right, I'm going to teach you a trick with the calculator, and I'm gonna try to end on this trick too because it's really important that your calculator is set in the right thing. And I'm going to actually make this messed up. Okay, so what'll happen is if you look at this thing for this particular column, you can say, oh, at 90, I'm guessing it should be 1, and it should. And this is actually something called the sine. It's SIN. It looks like sin, but it's sine, which we'll talk about in a minute. And it's on your calculator. And we're going there, but I want to point this out because it's super important. Sine of 90 should be 1. If I do sine of 90 and I hit equals, and it is not 1, you are in what's called radians, which we haven't talked about. But someone has left your calculator in a state that you're going to get every single thing on the SAT wrong. So you need to make sure that the sine of 90 is 1. And I'm going to go into my setup because I know how to do this. And there's something called degrees there, which is what we're measuring in. I'm going to do that. And now, if I do sine of 90, it is 1. I'm going to remind you that again and again and again and again, because otherwise your calculator is never going to give you a right answer. So we'll talk about that again at the end, about why is it sine, what does that mean, and all that. To start with, we're going to do something simple. We're going to do a 3, 4, 5 triangle. 3, 4, 5. Pythagorean triple, 3 squared plus 4 squared equals 5 squared. And if we wanted to figure out what this angle right there is, one of the ways that we could do that is we could say, well, I'm going to grab 2 of my numbers, maybe my opposite and my adjacent. So my opposite over my adjacent is 3 over 4. That is 0.75. And I go look in my chart under opposite over adjacent for 0.75. It's not there. It's somewhere between 30 and 40 is 0.75. So I might guess, my guess might be 35 degrees. And the question is, well, can I find out exactly what that is? And you can. And one option is to have, there's a table that you can look at, which I don't know how well you can see. But if you look in this table, the third column here is O over A. And if I go down to it and find 0.75, oh, good, it got bigger. 0.75, oops, is roughly 37 degrees. Oh, you can't see that. It's basically 37 degrees. So I'm doing the same thing. I just got a table that's broken down by ones instead of 10. So I'm doing the same thing. And I go in there and say, oh, okay, this is actually not 35 degrees. It's actually 37 degrees. And it may not even be exactly 37 because the number that was on the screen there was 0.75, I think 33. So it wasn't exactly 0.75. It's maybe a little bit less than 37 degrees. But that's something we can do with our table. If I opposite over adjacent, look in that column. If I had grabbed these two, 3 over 5, I would have gotten 0.6, and I would have looked in the opposite over hypotenuse column. As a reminder, that's my hypotenuse, opposite adjacent. Okay, so that's one thing we've done. Another thing we've done is I might give you maybe a slightly longer, narrower one, where maybe I tell you this is 20 degrees to start, and I say, hey, this is 10, and I'd like you to find this leg over here. Which is like, oh, I totally know how to do that, because I know this is the opposite from this reference angle over here. This is always the hypotenuse. I don't need to know it, but this down here is the adjacent. And I can say, oh, okay, x over 10 is my opposite over my hypotenuse. I go to my chart for 20 degrees and say 20 degrees opposite over hypotenuse is 0.34. There is an equation I can solve. Many times we like turning this into a proportion. And so if I cross multiply, x times 1 is just x, and the 10 times the 0.34 is 3.4. And I'm like, oh, that kind of makes sense for that picture. That looks about right. So that's something else we've done. Now, where we're going with this is, what if I started with 37 degrees? What if I started with this? And we're going to do this even though we know the answer. We're going to say I'm going to make a triangle that's twice as big as my 3, 4, 5. So even though it's twice as big, it'll be 6, 8, 10. This is still going to be 37 degrees. So I do my 3, 4, 5, but I'm going to make it 6, 8, 10, except I'm only going to tell you this is 10. We're going to find this, and I'm going to tell you this is 37 degrees. Now, we already know what the answer is supposed to be there. It's supposed to be 6 there, 6, 8, 10. Okay, but we're going to say, well, can I figure this out? Now, the problem we have here is our chart doesn't do 37 degrees. Our chart only does 30 and 40, and we're looking at opposite over hypotenuse here. So I'm looking right here. So the question is, well, can I get it somewhere else? Well, I can get it from my other table because it's got all the numbers in between, but it'd be really nice if I didn't need to use another table. So I'm going to use the calculator. And this is where before, this is opposite, this is hypotenuse. This is what's called the sine. It's pronounced sine, but it's usually written like this, like sin, but it's sine. And the sine is the relationship between the O over H. It is literally, this is the column of the table we are talking about. This is the same table column. It's just a lookup for us. So for instance, if I looked up over H for 10 degrees, it's 0.17. Let's make sure that works. Sine of 10, 0.17, and then some other stuff that we've chopped off. So let's do it for 37. Sine of 37 is 0.60, that's in the right place for my table here. So instead of using my table, I'm just going to put it in here. This is basically looking it up in the table, but it's got more rows than my table has. So I know x over 10 is equal to 0.6018. In my calculator, typically we go to 4 decimals when we use it out of our calculator. And then when I cross multiply, same thing I did last time. X times 1 is just x. It's 10 times that. I'm just moving the decimal over one place. I don't need a calculator for that. Hey, there's that 6 I was expecting. It's not quite 6. And the reason it's not quite 6 is this is not actually 37 degrees. It's actually a little bit less than that, which we'll get into later about, well, could I find out exactly what that was? Yeah, we could, but we're not going to worry about that yet. Okay, let's do a different type of example. Let me look at my notes over here. So let's say that I did it with the calculator, did it with the table. Where's my next set of notes? 3, 4, where's 5? There's 5. Okay, let me switch colors. Let's say I have something that almost looks like half a square. It's going to be almost really hard to tell. And I'm going to say this corner is 43 degrees. It's almost half a square. Okay, bad picture. Make it look like that. Okay, half a square. 43 degrees. This is a slightly smaller, which would make this one over here 47, because I've got to add up to 90. This would be a slightly smaller side. This would be a slightly larger side, because small side's opposite from small angle. But like if one was like, if this was down here was 8, I might expect this to be like 7.9. They're going to be super close. All right, and I'm going to give you a number. I'm going to say this side is 5, and this one is x. And once again, the S and the L I'm going to scratch out. It just means small and large. So if I put 5 there, I'm expecting something a little bit bigger than 5. All right, so we're going to use 43 degrees. Now, here we have opposite over adjacent, if I'm using 43 as my reference angle. The name for this that I look up in my calculator is tangent, or just tan, which is the same as saying, hey, go get that third column in your book, in the table. So I'm going to do that in my calculator. I'm going to say tan, which is right here, and I'm going to type in 43, and it's going to tell me, hey, that's 0.9325. So 0.9325 is what that is in my table. And if I actually look at my table for just above 40, that seems like it would be right. It would be right in there. Okay. And I know that's got to equal my opposite, which is 5, over my adjacent, which is x. Now, in this case, when I cross multiply, I end up with 0.9325 times x. 0.9325 times x. And then when the 5 and the 1 gets multiplied, I get 5. Okay. And a lot of times when students get this, they get a little confused what's supposed to do, and I have to simplify it. I said, if I gave you 2x equals 10, what would you do? And they're like, oh, that's easy. I just divide both sides by 2. Okay. That's what you do here. There should be a 2 in there. I got 0.9325x equals 5. I just divide both sides by that 0.9325 on both sides. 9325. Kind of a mess. I'm going to do that in my calculator. 5 divided by 0.9325, and I get 5.36, which is what I'm expecting there. I'm expecting that to be a little bit larger. I think I misspoke last time when I said that would be smaller. 47 should be opposite from the 5.36, and the 43 is opposite from the 5. Okay, I've about run out of time. I think I had one more thing I wanted to do. Okay, yes, it's worth the extra minute. The extra minute, so here's what you have to remember. Sine is opposite over hypotenuse. That's our first column. Cosine, which we haven't seen, is adjacent over hypotenuse. And tangent is opposite over adjacent. Most people who have taken geometry before remember something called SOHCAHTOA. And that's how you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. This is just a way that you can tell, hey, which button do I press for which column did I want in my table? The other thing I wanted to point out to you is if you are using a phone, I want to show you where you can find that. So normally your phone looks like this, like where's my sine and cosine button? Most of you probably know if you rotate it, because that's where your square root is too, so hopefully you know where that is. You will notice there is a sine, cosine, and tangent button there. And so I got 90 in there already. If I hit sine, I got 1. Let me show you if that's in, see that radians button right there? Now I'm in radians. So if I do 90 and hit sine, I do not get 1. So once again, so I'm going to go back to degrees. 90 sine gives me 1. And notice on the phone, you type in the 90 first and then you hit sine, or on this thing, you actually you do the sine first, and then you hit 90. And that's 1. Okay, SOHCAHTOA, say it, SOHCAHTOA. That's 12 minutes, sorry it ran a bit long.